Welcome to this lesson on the abstract factory pattern, one of the classic creational patterns from the Gang of Four. By the end of this video, you will understand the problem it solves, know the named roles in its structure, be able to write a minimal implementation in TypeScript, and just as importantly, know when to skip it entirely. Imagine you are building a UI toolkit that supports both a light theme and a dark theme. Every theme requires its own version of several widgets, buttons, checkboxes, dialogues. The catch is, those widgets must match each other. If you just call new dark button and new light dialog in separate places, you end up with an inconsistent UI and a codebase where theme knowledge is scattered everywhere. Swapping themes later means hunting down every one of those construction calls. Think of a furniture store that sells complete room collections. You can order the Victorian collection or the modern collection, but each collection contains a matching sofa, chair, and coffee table. The store guarantees every piece in a collection goes together. You never have to worry about mixing styles. You just pick a collection and order from it. That is the core idea behind Abstract Factory. Pick one factory, get a guaranteed compatible family of objects. The Abstract Factory pattern defines an interface, the Abstract Factory, that declares one creation method per product type in the family. A concrete factory implements that interface for a specific variant, such as dark theme factory or light theme factory. Each method returns an abstract product interface, so the client never references a concrete class directly. The client is fully decoupled from which family it is working with. It just calls the factory methods and uses the returned interfaces. Let us walk through this step by step. First, we declare two abstract product interfaces, button and checkbox, each with a render method. Then we write two families of concrete products. Light button and light checkbox form the light family. Dark button and dark checkbox form the dark family. Next, the abstract factory is the theme factory interface with two creation methods, one per product type. The two concrete factories, light theme factory and dark theme factory, each implement those methods and return only their own family's products. The client function render UI accepts a theme factory, calls create button and create checkbox, and renders the results. It never mentions any concrete class. At the bottom, we wire it together. We choose a factory based on a runtime argument, then pass it into render UI. Swap the factory, and you get an entirely different, fully consistent set of widgets. At runtime, the client receives exactly one concrete factory, usually injected at startup or through a config value. Every object it needs comes from that single factory, so compatibility is enforced structurally, rather than by convention. The important trade-off to internalize is this. Adding a new product family, say a high-contrast theme factory, is trivial, just write a new class. But adding a brand new product type, say create tooltip, requires changing the abstract factory interface and every concrete factory that already exists. The pattern optimizes for family extension at the cost of product type extension. Reach for abstract factory when you genuinely have multiple product families that must stay internally consistent, and when the client code should remain unaware of which family it is operating on. Cross-platform UI toolkits and database driver layers are classic fits. Skip it when you only have one family, when your product set changes frequently, because every addition forces you to update every factory, or when a simpler mechanism like a DI container already handles object creation cleanly. To summarize, Abstract Factory gives you a single interface for creating an entire family of related objects, and the concrete factory enforces that every product in that family is compatible. The client stays decoupled from all concrete types. The major trade-off is that the product type set is essentially fixed. Expanding it is expensive. Reach for this pattern when you have multiple coherent families and a clear need to keep creation logic isolated from the rest of your application.